Hello and welcome. I'm Adam with Push the Envelope, the channel that gives you everything artificial intelligence and machine learning. Well, you made it to the very end. This is going to wrap up our Python Bootcamp series. This episode, we're going to be looking at where do you take your Python skills next. Up until this point, you learned the very basics and you put those all together to solve a real-world problem. But now we're going to be looking at some of the most common packages that you can use in order to read in data, manipulate data, and actually visualize those in charts. So without further ado, let's jump over to Jupyter and we're going to learn about the Pandas package and the MatPlotLib PyPlot package. Okay, our notebook is up. As you can see, GitHub link at the very top. It will also be in the description of this video. This is where you're going to find all the templates, solutions, and files we will be using. Now for this one, you don't necessarily need to use the templates that I give you, but they may help you with some of the files and reading in the data, and along with seeing some of the headers that we're about to be using. But this first notebook is going to be exploring Pandas. Now, Pandas is a data science tool that lets you read in large amounts of data very fast and lets you manipulate the data, change the data, add things to the data, whatever you may want to do to it. So let's go look at how do we actually start using Pandas. First thing we need to do, this is not something that is commonly included with Python. So you will need to install the Pandas package. Now, if you're using something like Anaconda that's meant for data science, this may be included. In fact, in Anaconda, it is already included. But for everyone else, you will need to download this. So in order to download this, couple ways you can do it. You need to go to your command line for most people, and you need to do a pip install pandas. You need to type these commands, run that, and that will download pandas for you. Now, something different for other people, if you're using Anaconda, instead of using pip, you're going to want to use conda install pandas. Anaconda has its own package management system, and so you're going to want to keep using that one as much as possible, though you can find it using pip as well. Okay, so that's how you do it through the command line. You want to type in these commands. But if you're using Jupyter Notebook or Jupyter Lab, you don't need to worry about going to the command line. You can actually just execute that from these cells right here. And the way you do that is by providing the exclamation mark. So, exclamation mark conda install pandas or exclamation mark pip install pandas. Either one will work. If you're conda will only work though if you're using Anaconda. So if you run this, it will think for a second and then it will start to download the package. If you already have the package installed, like I said, this automatically comes with conda. You're going to see something about the package already being installed. So go ahead and run that. Download the package if you haven't already, and we will move on. I'm actually not going to worry about downloading the package for now because I already have it installed, so I don't need to worry about it. All right, once you have this package or any package that you want to use installed, you need to import them. Now, this may be a review from when we were importing the random module or some of the other things that we did, but it's just a typical import pandas. Now, this will import the pandas package, and whenever you want to use it, you just say pandas dot, just like we had import random, and we use random.random to grab the function. Now, with pandas and some of the other packages, it's common to say import pandas as PD. What this means is you're going to import the pandas package, but you're going to use this name PD, and so that every time that you want to use it, you don't have to type out pandas every time. You can just type PD dot. So just a way of renaming the package to make it a little easier to use. Something else that may be useful is sometimes you don't want to import the entire package, but you only want to import maybe some sub functions or something like that. So if I say from pandas, so it's going to reach into the pandas package and it's going to import the read CSV file in this case. Read CSV is going to be a function within the pandas package. And it's only going to import the read CSV function from pandas, so you can use that. So those are a few ways that you can import the package. You can run all these if you wanted to. I am going to revert to only using import pandas as PD. Okay. So if you remember how we had to use the for loop and read the entire file and then do a lot of string manipulation and all that sort of stuff. So I'm going to show you how easy Pandas really makes it to read files. I know we kind of suffered reading through files before, and that was mostly for learning. When you actually do it in the real world, you can do it a lot quicker and a lot faster. There's a lot of packages out there for you to do this sort of stuff. So if we go back to looking at what the file looks like, we have this date open close. This is the stock data. We have date open close. We have all of the dates followed by commas with the open and closing. So if we go back to our pandas, and so now I'm going to say stock file is equal to pd.read underscore CSV. And I'm going to read from the files folder, and this is called stock data.txt. Now, you can see that this function is called read CSV. CSV is called a comma-separated value file, and it's a common way of storing values, almost like an Excel file. But when you read them as text files, all the values are separated by commas, which happens to be exactly how our data is stored within this text file. You could also store it as tabs. That would be a TSV. There's other ways of storing it with other delimiters. Delimiters. So we actually are just going to pass in our delimiter is equal to a comma, just to let it know, hey, all of our values are separated by commas. Now, one thing you can do in Jupyter Notebook and Jupyter Lab is instead of printing this out, you can actually use something called display. And I'm going to display the stock file. And this is just a better way of viewing the data. You can see it's very tabular. You see all of our lines, see all of our columns. And just like that, in one line, we read in the entire TXT file. Now I could do this again. I also have the shares, which are over here. You can see we have date and shares, again, separated by a comma. So if I come back here and I copy both of these, and now I'm going to call this one the share file, and I'm going to read my underscore shares.txt with the delimiter being the comma again. Now if I display the share file as well, you can see first one is our stock data, second one is our share data. Immediately puts it into a data frame that we can use in the future. Okay. So we have that. I'm going to comment out the displaying the share file because we're only going to focus on the stock file right now. So again, we have date, open, close. Now, if I wanted to create another column, like if you remember in the capstone project, we calculated the changes by subtracting the closing minus the opening prices. I can remake another column. So stock file at, and now I'm just going to add a new column name. So I'm going to say change. So I'm going to make a new column called change, and change is going to be equal to the stock file at the closing column minus the stock file at the opening column. Now if I display stock file, you can see it immediately adds this other column, subtracts the closing minus the opening, and adds it as a new column within the data frame. So very, very easy operations to get what we're trying to do. We don't have to use all the for loops and loop through the data. It just immediately does it for us. And that's really the power of using some of these packages that people have put together. So now if we're looking at this file, we have our date column, open, close, change. If you remember, the shares had the date column and then it had the number of shares. So one thing you can do is combine these two files together. So if I say the combined data frame is going to be equal to the stock file dot merge. So we're going to be merging two files together. We're going to merge it with the share file. And again, the thing in common between the two is the date column. So on the date column, we're going to merge using a left merge, which means everything within the stock file is going to remain the same, and it's going to match as best with the share file as possible. So now if I display combined, you're going to see that we have our date column, but now we have the shares matched up to when those dates are. So all in one file now. We don't need to worry about reading multiple files, using for loops, and then combining them all at the end. Kind of just does it all for us. Another thing that we did within the capstone was to say we made the diffs. So diffs, we're going to make a new column called diffs. And diffs was equal to the change times the number of shares. So we're going to take our combined data frame at the change times our combined data frame at the shares. This is going to give us a new column, and those are all the difference values. So again, in 4 lines, we were able to do the first probably 5 steps within the capstone. So again, really why you want to start using packages, because people have taken care of a lot of this work for you. So you don't really have to suffer through how we were doing it before. All right, we also at one point wrote the differences to a file. So now if I say our combined file is equal to the combined file, and I only want the differences column. So I'm going to use this double bracket right here. So I only want the differences column, and I display combined. You can see it's only the differences column. If I want to write this to a new file, I can just say combined.toCSV instead of read CSV. ToCSV will save it. And I want to write it to files/myaccount.txt. Now, if you can see on the left-hand side here, we have this index column. You don't, if you write this to the file right now, it will save that index column. You don't have to send it. You can say index is equal to false. You can also say I don't want headers either. So I can say header is equal to false. This is going to be exactly what we had before. So if I go and open up my account, you can see that these are all the values, and it's going to look exactly like it did before in our capstone project. Okay. Let's go to, all right, so one other thing we did was we took all of the differences and created a running sum. So we started with 10 grand, we added all the differences to it, and then came out with some sum at the end. Again, Pandas is going to make this super easy for us. And so in order to do that, I can just print out, we started with 10,000. I want to say minus the differences column. So combined at differences dot sum, and dot sum is going to just sum everything within the column. So we're taking everything within the column and subtracting it from our $10,000. Okay, doing this, you can see, oh, this should be plus. There we go. Not subtracting, we're adding it to it. So our difference is 5,627, which is exactly like it was when we were calculating this in the capstone. One other super useful thing, so if I display, I'm going to go back to when we had the stock file. So you can see we had our date, open, close, and change. One thing that I can do is I can filter this data frame super quickly. So if I display instead, actually I'm going to just come up here and change my display statement here. So if I want to display the stock file where the stock file, I'm going to use a bracket within a bracket here. So I'm going to display the stock file where the change column is greater than 10. So any change greater than 10, I want to display. If I run this, you can see it has filtered down the list to only show me where this change column is greater than 10. So you can do a lot of stuff like that, filtering, getting what you actually want, and lots of changing the data. I'm going to stop with Pandas for now. That's just a quick overview. I have multiple videos on Pandas and how to use it. Definitely goes way more in depth. This is kind of just intended for a quick overview of some of the cool things you can do with it, just to get your mind going of what you may be able to do next and kind of point you in the right direction. Next, I'm going to show you how to use MatPlotLib. MatPlotLib is a way of allowing you to make a whole bunch of charts and pie charts, line bar, whatever you may want to do. Again, you're going to need to install this, so you can pip install MatPlotLib. If you're using Conda, you can Conda install MatPlotLib. If you're going to do it using Jupyter, then you want to include this exclamation mark. If you're going to do it in the command line, get rid of the exclamation mark. But go ahead and download that. Again, I'm not going to run it because I already have it installed. But in order to import this one, you're going to say import matplotlib.pyplot. Now, this is a little different. We didn't show this in Pandas, but this is going to look in the matplotlib package. It's going to look for the pyplot folder, which has it's a sub package within matplotlib, and we're going to be importing this as PLT, so we don't have to type out this long string every single time. We just need to type out PLT. So import that. I am going to read in the file using pandas just because it's easier. So import pandas as PD. We need to make sure that we have that package in and ready to use. And again, it's data equals pd.read CSV. It's looking for where our file is located. So files/stock data.txt. Same file we've been reading in the last one. The delimiter will be equal to the comma. Okay. And I'm just going to display data to see what it looks like. Cool. Date, open, close. Now, one thing that I didn't show in the last one, this date column is really a string. And so you can convert dates to actual date times within Pandas by using a built-in function. So I can say the date column, I'm going to reassign it to be pd.toDateTime, and I'm just going to pass in the date column. So it's going to be taking the date column, converting it to a Pandas date time, and then saving it back as that column right there. So if I run this, you're not going to be able to see anything because it's going to look the same, but this is now a date time instead of a string. And it's going to help us when we go to make some of our charts. Like we did before, we're just going to make a change column that's going to be equal to the closing price minus the opening price. And I'm sorry if I'm going fast again. It's not really intended to be a how-to video for Pandas and MatPlotLib. It's really just to show you what you can do, and I'll point you into the right directions for how we can actually use these. I have a few videos on them. One last thing. I'm going to make some bins. And basically, I'm going to look at the percent changes. So I'm going to look at how much the amount has changed for the day. So another built-in function is cut. I'm going to cut the change column into these bins right here. So the first bin is going to be -200 to -2. The second bin would be -2 to 2, and the last bin would be 2 to 200. Okay, and then I'm going to label these bins to be equal to negative, none, positive. Again, sorry if I'm going fast. I will show you exactly what this does right now when I run the code. So running this, you can see it's looking at the amount that was changed. If it's between -2 and 2, it's going to label it as none. If it's less than -2, then it's going to label it as negative, and if it's greater than 2, it's going to label it as positive. So just giving us kind of these bins. You'll see why in a second. Let's move on to actually using PyPlot. So again, PyPlot is a way of visualizing your data as charts. So I can make a chart. So plt.plot. I'm going to plot the date column. It's a capital D. I'm going to plot the date column on the x-axis, and I'm going to plot the closing price on the y-axis. plt.show will show the chart, and you can see we have our chart. So these are all the closing prices. Now, if I wanted to make the chart bigger, I can say plt.figure. fig size equal to, let's say, 15 by 7. Makes it a little bigger. And you can see there's all of our data. Bottom will give us all of our dates. The y-axis will give us all of our closing prices. Now, not only can I print one, I can print multiple. So if I copy this plt.plot and I put one right under it before the show, I can also print and plot at the same time the opening price. Now I can say I want the closing price to be equal to red, so the color is going to be red. And for the opening price, I want the color to be equal to blue. Running this, you can see, and it's overlapping, so you can't really tell, but the red is going to be our closing price, and the blue is going to be our opening price, and you can see both of those are plotted at the same time on the chart. I can do other things. I can say plt.title, so I'm going to set the title to be, in this case, it's Tesla price. I can set the X label to be date. I can also set the Y label to be price. Running all that, you can see it's just making the chart a little fancier. You can keep doing that sort of stuff. You can add a legend. You can add a whole bunch of other things to it. But that's the very simple line graphs. Super helpful. Again, visualize data super quick. But we'll move on to some other things. So I can kind of take the same things. I'm actually just going to copy everything I did here for the line graph, move it down here to scatter plots. Now, instead of using plot, I'm going to say plt.scatter. And I'm going to do that for the second chart as well. And so now when I run this, you can see we now have a scatter plot. And these dots are fairly large. So I can reduce the size. Now I want to say the size is equal to 5. When I run this, you can see the dots are now smaller and it's a little easier to actually visualize the data. But again, another way of plotting out your data is using a scatter plot. Moving on, 2 more examples for you. I'm going to show you a histogram. And so if I'm going to make plt.figure because I know I need to increase the size of it just to make it a little easier to see. So fig size 15 by 7. We're going to do a plt.hist for histogram. And we're going to make a histogram of the change column. If I go ahead and run this, I need to do a plt.show. You can see we have this histogram, and sorry, my video is in the way. I can actually just reduce the size of this, and maybe it will be a little better. Let's go 12 by 5, maybe. Yep, all right, so that's a little better. You can see we have our histogram. If I want to change the number of bins that we use for the histogram, maybe I want to say bins is equal to 40. You can see it just increases the fidelity of the chart. But very quickly showing a histogram. Again, you can change the title, the X label, the Y label, whatever you may want to. Last thing I'll show, if you remember, we had that column called bins, and bins was giving us a categorical value of whether it was negative, no change, or positive change. So I can say plt.figure. Fig size in this case, we'll set it equal to 12 by 12. I'm going to do a plt.pie chart. And our pie chart is going to use that bins column, so data at bins. Now I need to grab the value counts, so I want to know how many of each of these are in there. So dot value counts, dot values, so this is going to grab the values. So the accounts for each of these categories. Now my labels is going to be equal to the same thing. But my labels, instead of the values, are actually going to be the other half of it, of whatever the actual name of the thing was, which is index.values. Don't worry about the syntax again. Other videos will describe exactly what we're doing here. I'm not intending to show you exactly how to calculate these things. But if we go ahead and run this, I do have a error. I call this bins when it should be bin. Okay, you can see our pie chart is way too big. So let's go 7 by 7. We have a pie chart, shows the breakdown of each of these different categories, whether it's positive, negative, or none. We could add titles, we could add whatever, but that is where I'm going to end it for MatPlotLib. Now, like I said, lots of different things you can do with this. I'm going to pull up one more thing here. These are some of the packages that you could look at. So some of the common Python packages, a lot of these are already built into Python. You can use these math for more complex math operations. We used random before. OS lets you look for files, so you can look within a folder to see what file names are or navigate to different folders. Regular expressions are more string editing and string searching. Time grabs system times. You can parse websites with these next two, URLlib and requests. PyTest are some test functions that you can use to test your code as you're writing it. As we go down, you got other ones like data processing stuff. So you're importing pandas. You can also import NumPy. NumPy is another way of manipulating data and creating data really fast. Visualizations. So you can have PyPlot like the one we just had, but there's other ones like Plotly, Seaborn, Pillow, and OpenCV are for image processing. So you can import images and do things with them. And lastly, machine learning. So sklearn, PyTorch, TensorFlow, Terras. Those are the 4 most common machine learning packages that you can use if you wanted to go down that route as well. But just a sense of some of the packages you can look at, where you should go next. But that is going to completely wrap up our series. On that, I will end it here. And I hope to see you in some of my other videos. Again, I'm going to link to the more in-depth pandas and pyplot videos that I have out there to give you a better sense of how to use those. But thanks for tuning in, and until next time.